Alright, in this lesson we're going to be doing the rational root theorem. So this theorem is going to tell us some more about the graph and do it by looking at the equations. We're going to get started on that. A rational root theorem. The word rational just means it can be written as a fraction, right? So like square root of 3 is not rational because I can't write that as a fraction. But like 1/3 is rational. 2 is rational. So fractions and whole numbers are rational, but repeating decimals are not. If you have the square root of 4, which equals 2, that's fine because it's equal to 2. But any square root that's not a perfect square is not rational. Right? That's just what rational means. And then roots are just other names for zeros. So it can also be called the rational zero theorem. But the more common name is the rational root theorem. By using this theorem, you get a list of all possible rational zeros. Now, this will not tell you the zeros for square roots, like some of the ones we did when we factored. The zeros were square roots, so it's not going to tell you those, but it will tell you all the rational ones. It also will not tell you the non-real solution. So we talked about how some have i's in the answer. This will not be on this list either. This will only tell you zeros that are whole numbers and fractions. Right? So the way you do this is you take the factors of the constant over the factors of the leading term. Right? Factors of the constant divided by factors of the leading term. Right? This will not work if there's no constant. If you have no constant, you can't use the rational root theorem to help you. So what this will do is, in the next few lessons, we're going to learn a different method to find zeros other than factoring. And this method will make it easier because you'll have a list you can narrow down using the other methods we're about to learn. Right? So this just gives you a list, and then from the list you can narrow it down to exactly what they are. Right? So that's what the rational root theorem is. Right? So this will take the factors of the constant over the factors of the leading term. So we're going to practice this one. So for number 1, first we do factors of the constant. So factors of 4 over factors of the leading term, which is 1. Right, so first we list all the factors. Factors of 4 are 1, 2, and 4. Factors of 1 are 1. Right, so you list the factors, and now we use this to make a list of all the possibles. So we start here. 1 over 1 is 1. And it could be positive or negative. Factors of 4, these are all positive or negative. The next one would be 2 over 1 is 2. And 4 over 1 is 4. So 1, positive or negative, 1, 2, and 4 are the possible zeros of this polynomial. To narrow the list down to get the actual zeros, you have to use one of the methods we'll learn in the next couple days. Right? But these are all the possibles. In our next one, we're going to do the factors of 8 over the factors of 3. So we have positive 1, 2, 4, and 8 over 1 and 3. Okay. So we'll start. So now this time we have 2 numbers on the bottom. So first what you do is you do all of them over 1. So 1 over 1 is 1. 2 over 1, 4 over 1, 8 over 1. Then you go back and do all of them over 3. So 1 over 3, 2 over 3, 4 over 3, and 8 over 3. So this one has a lot of different options for it. So the bigger the numbers, the more options you're going to have. Right? So we'll talk about how to narrow that down in the next couple of days, but these are all the possibilities that you have. And one more, number 3. So factors of 16 over factors of 4. So 16 is 1, 2, 4, 8. 16, 4 is 1, 2, and 4. Okay. So now we're going to start with everything over 1. That'd be 1, 2, 4, 8, 16. Now we'll do everything over 2. So it'll be 1 over 2. 2 over 2 is 1, and that's already on the list. It's already on the list. You don't have to write it again. Right? So 2 over 2 is 1. We already have that. 4 over 2 is 2. We have 8 over 2 is 4. We have that. 16 over 2 is 8, which we also have. Right? So the only new one we got using 2 on the bottom is the 1/2. Right? So let's go to the next one. We have 4. So 1 over 4. It's a new one. 2 over 4 is 1/2, which we have. 4 over 4 is 1, we have. 8 over 4 is 2, which we have. And 16 over 4 is 4, and we already have that. So when you get numbers like 4 and 16 that have something in common, like a GCF, or common factors, you may not have as many possibilities just because the fractions are going to reduce back to the same thing. So like with 8 and 3 have no common factors, so we got more out of that one because of the fact that it didn't have common factors. But 4 and 16 had common factors, so we had a lot of these fractions that were made reduced back to the same thing. It kind of saved us a little bit of lists there. Right, so that is rational root theorem. So again, rational root theorem just gives you a list of the possibilities, right? It doesn't give you exact answers. You need other methods to take that list of possibilities and narrow it down. So tomorrow we'll learn how to do that. But for right now, we need to practice making this list. If you have any questions, let me know.